Hello everyone. We are going to talk about standard SID 3 that states I can use shape, center, and the spread to describe characteristics of the data set. I can understand the effects of outliers on a data set. Alright, this standard is day 7 of your notes, and of all the material that you're working on your own, this is the most difficult. Okay, when you do get back, we will show you how to do this with a graphing calculator, but it's really important for you to understand what exactly the graphing calculator is doing for you. All right, our first word is a variance. The variance is defined as the average of the squared differences from the mean. To calculate the variance, follow these steps. Work out the mean. The mean is the simple average of numbers. Then, for each number, subtract the mean and square the result, the squared difference. Then work out the average of those squared differences. Now, to me, that all seems very confusing, so we're going to go ahead and practice a few so that you can see what exactly this is talking about. We are going to calculate the standard deviation. It's a measure of how spread out numbers are. The symbol for it is the Greek letter sigma. The formula is easy. It is the square root of the variance. So now you ask, what's the variance? Here we go. Our first image is you and your friends have just measured the height of your dogs in millimeters. The heights at the shoulders, so we're looking at the shoulder of each animal, is 600 millimeters, 470 millimeters, 170 millimeters, 430 millimeters, and 300 millimeters. Okay, so what's done first? Just the regular average. Okay, we just worked on averages in a previous lesson. So we add the numbers together. There's 5 dogs. Okay, when you add them together, you get 1,970. You divide it by 5, and your mean is 394. All right, so what do we do next? Okay, well, our first dog measured at 600 millimeters high. So we go 600 minus 394 is 206. Okay, so then the variance is 206 squared. The next thing is, our next dog stood at 470. Okay, shoulder height was 470. So you go 470 minus 394 is 76 that you're seeing here. Okay, this is showing this line is the mean, and what we're reading is how far from the line is each mean. Okay, the next one. The next dog we measured was only 170 millimeters. So you go 170 minus 394 gets you your negative 224. And notice the negative 224 goes in parentheses because a negative times a negative is a positive. All right, the next dog. The next dog that was measured is 430 millimeters. Okay, so it's 430 minus 394, which gives you your positive 36. And if you notice, positive 36 then is going to get squared. The last dog measures at 300 millimeters. Okay, so we go 300 minus 394 is negative 94, translated down to here as negative 94 squared. Okay, so what does this mean? Well, we square each number. 206 squared is 42,436. 76 squared is 5,776. Negative 224 squared is 50,176. 36 squared is 1,296. And negative 94 squared is 8,836. Okay, like our other mean, we now at this time divide by 5. Dividing by 5 is 21,704. So when all the numbers were added up, we had 108,520 divided by 5 gives us this. So the variance is 21,704. But the standard deviation takes it just one step further. It wants the square root. So On a graphing calculator, what would that look like? Well, you would do shift and x squared, and you would type in 21,704 and hit execute. That gives you 147.32 or 147. If you're my student, I'm pretty particular. I like you to round to the hundredths place unless they specify. Okay, that is our first example and the most difficult of all the examples we're going to do. We are now going to move on. This is much more like it. All right, here's our next data set. 1, 2, 2, 4, and 6. First thing we need to do is calculate our mean. So 1 plus 2 plus 2 plus 4 plus 6. Okay, 3, 5, 9, 15. 15 divided by 5 is 3. Okay, and that's what's shown down here. You take the numbers and you add them together. You divide by how many numbers there are. You get 15 divided by 5 is our 3. Step 1. Step 2 is you have to subtract the mean from each of the data values. Okay, so we had these 5 data values, and you see them reflected right there. There's your 5 data values. So you go 1 minus 3 is negative 2. 2 minus 3 is negative 1. 2 minus 3 is negative 1. And 4 minus 3 is 1. 6 minus 3 is 3. Okay, so the mean is subtracted from each of the beginning numbers. These are your differences. The third step is you take each of these differences and you square them. So our first difference was negative 2. Negative 2 squared is 4. Our second difference is negative 1. Negative 1 squared is 1. We again have a negative 1. We square it, we get a 1. We have a 1 squared, we get a 1. And a 3 squared, we get a 9. This is our list of squares. You take that list and you add them up. So now you're finding the mean of the squared numbers. So 4 plus 1 is 5, plus 1 is 6, plus 7 is, plus 1 is 7, plus 9 is 16. Then you take 16 and you divide it by 5 to get 3.2. Okay? Once you get the 3.2, this number represents the variance. Okay? And the last step, to find the actual standard deviation, you go shift, x squared again, 3.2, execute, and for me, rounding to the hundredths place, this 8 changes that 8 to a 9. Therefore, your standard deviation is 1.79. All right, our last example really gives us none of the work shown, so we have to do everything on our own. Okay, the number of red vines eaten during a movie is listed. Identify the outlier and describe how it affects the mean and the standard deviation. All right, so what is my outlier? 20. 20 doesn't belong with the rest of the numbers. Like before, we're going to do outlier in, and we're going to conduct outlier out. Okay, so with the outlier in, what's the mean? So I'm just going to take a calculator. I'm going to add these up. 3 plus 5 plus 5 plus 7 plus 9 and 20 divided by 1, 2, 3, 4, 5, 6. Okay, my mean is 8.17 rounded. Okay, that's with the outlier in. Now, if I remove the outlier, I have to re-add the numbers 3 plus 5 plus 5 plus 7 plus 9. And instead of dividing by 6, I just removed one of the numbers. I need to then divide by 5, and I get 5.8. Okay, so what does the outlier do? Well, we take 8.17 and we subtract 5.8, and we get that it increases by 2.37. Okay, that's what's going on here. So with the outlier in, it increases the mean by 2.37. Now for our standard deviation. Okay, our standard deviation states that we had, I'm gonna go back just to make sure I don't screw this one up. 3 plus 5 plus 5 plus 7 plus 9 plus 20 divided by 6. 5 plus 5 plus 7 plus 9 plus 20 divided by 6. All right, 8.17. So our mean with the outlier in is 8.17. Our mean with the outlier out is 5.8. All right, so where do we begin? Okay, we need to take our number and subtract 8.17 each time. So we begin with 3 minus 8.17 would be negative 5.17. We move on. 5 minus 8.17 would be negative 3.17. 5 minus 8.17 is again negative 3.17. 7 minus 8.17 is negative 1.17. 9 minus 8.17 is 0.83. And 20 minus 8.17 is 11.83. All right. Now, I'm going to rely very heavily on my calculator for the next step. I need to square all these numbers. Okay? So, I'm going to do it in one step. Okay? If you don't have a graphing calculator with you, you can just square one at a time. I strongly suggest that if you have a smartphone, you guys download an online graphing calculator. In the apps, I actually have, and I can just show you really quick, mine that I use is Wabbit, EMU. Okay, I found that one to be very, very good for my needs. All right, so moving on. Here we go. We're going to enter negative 5.17. I'm going to close it. I'm going to square it. Looks like that. Plus negative 3.17. I'm going to close it. I'm going to square it. Plus, again, negative 3.17. Close it. Square it. Plus negative 1.17. Close it. Square it. Plus 0.83. Close it. Square it. Plus 11.83, close it, square it, go. All right, so we have 188.8334, and that at this time needs to be divided by 6. Okay, and our squared differences are giving us 31.47. But our last step to calculate the standard deviation, the 31.47 is the variance. The standard deviation then is shift square root 31.47, and we get 5.61. My standard deviation is 5.61. Okay, not so fun, but now we have to do it with the outlier out to see how it's changed. Okay, so we already know our mean is 5.8. We've done that work. So we're going to go 3 minus 5.8 is negative 2.8. 5 minus 5.8 is negative 0.8. We repeat that number. 5 minus 5.8 is negative 0.8. 7 minus 5.8 would be a 1.2. And 9 minus 5.8 would be a 3.2. Okay, relying on my graphing calculator again, here we go. I am beginning with a negative. Sorry, let's get this to an area that you can actually read. All right, negative 2.8 squared plus negative 0.8 squared plus negative 0.8 squared plus 1.2 squared plus 3.2 squared. I get 20.8. Okay, with the outlier out, it's now 20.8 divided by 5. We've reduced the amount of numbers we have. So 20.8 divided by 5 is 4.16. Okay, 4.16 is my variance, but my standard deviation is the square root of 4.16. So shift square root 4.16. My answer is 2.04. All right, so now we just need to subtract 5.61 minus 2.04. So 5.61 minus 2.04, 3.57. So the standard deviation is increased by 3.57 when the outlier is in. All right, so a couple of things to note again is if you have a smartphone and you can download an app, WABBITEMU will give you a graphing calculator which will allow you to enter things the way I just entered. Otherwise, you kind of just have to take one thing at a time and record it as you go. All right, at this time, we have just concluded day 7 of our notes, and you need to complete your day 7 homework assignment. Thank you, and have a good day.